Now that we know how to run a test in JUnit, let's go ahead and see what's involved in actually creating a test class. So in a test class, we know that we have to set up a test method, but what should that method be testing? This is something that you need to think about. In general, you would be testing some functionality of a class or set of classes that you have written. Let's say we have a class called rectangle. Let's go ahead and set up some properties in this class. Now the rectangle class has two properties, length and breadth. These are the member variables of the rectangle class and they completely describe the rectangle. When a class has member variables, you usually set up getters and setters. These are methods that help you access and set the value of the member variables of the class. You can generate getter and setter methods in IntelliJ directly. You can also set up a constructor. The constructor basically sets the initial values of the member variables length and breadth. So now you'll have the getters and setters for length and breadth. These will be methods which are called get length, set breadth, set breadth, and so on. Now you can set up a method that actually does something in this class. For instance, you can set up a method called getArea, which will give you the product of the length and breadth, because the rectangle's area is going to be the product of its sides. Now that you've set up this method, you would actually like to go ahead and test whether this method works as expected. The general flow would be that you set up a rectangle and then you set up the length and breadth of that rectangle. Then you would check if when you call the getArea method, it returns the product of those length and breadth values. So this is exactly what we'll do in our test method. So we will go back to our test class, and in that test class, we need to follow 3 steps. These are the 3 general steps that you would follow in any test method. The first step is to create an instance of the object that you actually want to test. So in this case, we want to test the rectangle object. So we are instantiating a new rectangle. We are also specifying the length and breadth because you need to do that according to the constructor that we set up earlier in the class. So we are passing in the values 4 and 3 for the length and breadth of this rectangle. So this is the first step. You create the object that you want to test. The next step is to actually call the method from that object that we want to test. So the method that we want to test is the getArea method. So we will simply go ahead and call this method. Now when we had set up the getArea method, we specified that it returns a double. So we will store the result of the getArea method in a double object. So till now, what have we tested? We have tested whether we can successfully instantiate a rectangle or not. We have tested whether we can call the getArea method or not. And we've also tested whether that getArea method will return a double. If all of these conditions are satisfied, then these 2 lines will run successfully within the test without an error. But all of this just tells us that the getArea method exists within the rectangle object and that it returns a double. Only these 2 conditions have been checked. The actual value that the area method returns hasn't been checked yet. This is where assertions come in. So using assertions, you can check whether the expected value of the area is equal to the actual value. The rectangle had length and breadth 4 and 3. This was what we set in the constructor. So the area of the rectangle should be 12. The area variable that is returned by our getArea method call should also have the value 12. So if the area is equal to 12, then we want our test to pass. Otherwise, we want our test to fail. This check is done using an assertion. the assert statement is basically a built-in statement within Java to do this type of check. Whenever you want to check whether a condition is satisfied or not, you can use the assert statement, and if the condition is satisfied, then Java will move on and run the rest of the code. Otherwise, it will throw an exception and stop. So here, for our test method to run successfully, the assertion should be true. That is, the area should be equal to 12. If we run this test and our getArea method is set up correctly in our rectangle class, then the assertion will be true and the test function would run successfully, hence giving us a result that the test is successful. Let's also print out a statement right after the assertion so that we know the assertion was successful. So we can run this code now and we can see that it runs successfully. So that's how you can write any test method. A test method should basically test the functionality of some class by calling some method in that class. The anatomy of a test can be broken up as: first, you create some object which you want to test, then call methods from that object. Then you should know beforehand what you expect as the output of those methods, and you should be able to put in a condition to check whether the expected output of the method is equal to the actual output when you call it during the test. This check of expected versus actual can actually be done using something known as assertions. Now, assert is a built-in statement in Java, but JUnit has an assert class with a bunch of static methods which help us to use assertions. We'll look at assert class and the assert methods that are available within that class and see how they can be used to write JUnit tests in the next video.